Good morning and welcome to Tuesday, April 28th. This is Algebra 1. Today we're moving on to our next unit, which is called Graphing Quadratics. This is Unit 6. All right, so obviously we have to graph, which I know is not everyone's favorite thing to do. We're graphing what we call quadratic equations. We've spent a lot of time looking at linear equations. So obviously, a linear equation is one that graphs in a straight line. All right? Looked at linear equations, linear inequalities. We solved linear equations and linear inequalities. It's time to move away from just the straight line. What makes something linear? Well, you've looked at many of these. Y equals mx plus b. So looking at y equals mx plus b, we notice something specific, hopefully. X never, ever, ever, ever has a power on it. We never see anything up in that corner. X is never being squared or cubed. There's never been a power on x in a linear equation. The reason is simple. If you add a power to the variable x, it no longer graphs a straight line. Okay, many of our functions from here on out have special names depending upon the power of the function. We call the power of x, we call it the degree of the function. A linear equation has a highest power of x of 1, the unseen exponent of 1. That makes it linear. If it's not 1, it changes the shape of the graph. So, with a quadratic equation, we get x squared. There can still be numbers involved. There could be a number in front of the x. It's not really called a slope anymore because it doesn't have a constant increase for every x increase. But it's still possible to have a coefficient there. There's also the possibility of numbers after the x squared. It's not exactly what you are used to seeing, but that's why we evolve our understanding of the math. So here's what I want you to see right now. And if you happen to have a graphing calculator on you, that's great. But if not, we can always use desmos.com, DESMOS.com. It's actually a very easy graphing website and it's free. So I'll show you how to use that as we go. What do you get when you graph y equals x squared? That's really the first question. So I'm going to give you a basic format for how we get the graph of it. All right? Basically, the graph of y equals x squared is going to have the shape we call parabola. What is a parabola? Well, how do we graph this? Take out graph paper if you have it. We're not going to get very complicated right now. So I'm just going to have my basic coordinate grid. In order to graph this function, I want to have a very small t-table. It's an xy t-table. We call it that because the lines in the center look like the letter T. I'm going to choose numbers. The easiest numbers to choose in the basic, we call it the parent function, because there's nothing else involved in the equation. Y equals x squared is as simple as it gets. I'm going to choose x values of -2, -1, 0, 1, and 2. I am choosing 5 input values. It is best to choose 5 input values so you can see the shape of the curve. Those are the easiest ones to choose. And each one gets plugged into the equation. So if x is -2, y is -2 squared. -2 times -2 is 4. If x is -1, y equals -1 squared. Be careful with your calculators. If you type in -1 squared, it's going to say -1, but it's wrong. Remember that the negative part has to be involved in the base. So you can use parentheses if you want. Parenthesis, -1, parenthesis squared. It'll give you the right answer. -1 times -1 is 1. If I plug in the number 0, y equals 0 squared, 0 times 0, pretty easy. It's 0. Now plug in a positive 1. Y equals +1 squared. +1 squared is still 1. And finally, if x is the number 2, plug in a 2. Y equals 2 squared. 2 times 2 is 4. What you might notice is that we have what we call symmetry in the outputs. And you'll see what symmetry looks like on the graph. -2, 4. So 2 to the left and 4 up, put a dot. -1, 1. 1 to the left, 1 up, put a dot. 0, 0. Right there at the origin. You can see it's curving now. All right, it was going straight, now it's curving. 1, 1. Well, now it's curved right back up. And 2, 4. Now it's over here. If we draw the parabola, it's going to have a curve like a U shape. We put arrowheads on the ends because it does keep going forever. And we formed our very first parabola. Okay? There's lots of things we're going to look at as it pertains to the parabola, to the parts of a parabola, what we call different parts of the parabola. We're going to do a little bit of that now. Let's do a quick for instance. All right. All right. We can see in the parabola that, and again, we read it left to right, like we read English, okay? So as we move from the left to the right, I want to ask you if you could tell me what's happening. So as it moves from the left to the right, if you were to call that a slope, you would say that that slope is negative or decreasing. This is decreasing. It's going down as we look at the graph from left to right until it hits this point where it turns around. This point is called the vertex. The vertex of a parabola is the place where the parabola turns around and stops its original path and goes in the opposite direction. So what do you think is happening on the other side of the vertex? Well, if you said it's increasing, you're correct. All right. So we have intervals of decrease as it's coming down from the left, and an interval of increase as it's moving up to the right. We'll talk about the notation for how we describe those intervals at a later date. We've got increasing, we've got decreasing, we've got vertex, we've got the word parabola. It also has to do with what the parabola looks like, because the vertex can be described in two different ways. Parabolas can do one of two things. And they also don't have to be located on the origin. It all depends on the equation itself, because the parabola can move around. It could also cross axes. So I gave you two different parabolas right here. Obviously, one of them looks like a smile. We call that opening up. It opens up because the arrowheads on either side are pointing up, meaning on either side of the vertex, it continues upwards towards infinity. So we say opens up for this one, the smile. The other one looks like a frown. On either side of the vertex, it's pointing down towards negative infinity forever. So we call that opening down. And obviously there are different things that make the parabola open up or open down. Now, if this is my vertex, because it is the place where my parabola turns, but it's opening up, my vertex has a special name. The vertex, in this case, is also called the minimum. It's called the minimum because the parabola itself never gets lower on the y-axis than that point. That is the lowest point on the y-axis that it can ever get to. But if it opens down, the vertex is again right here where it turns, and this time, this vertex is at the highest point it'll ever get to on this parabola. So it's called a maximum because in a parabola that opens down, the parabola's y value will never get higher than that vertex. It's at the very, very top before it turns over again. So we got some good vocabulary going on here. All right. There's lots of things we can do with different equations. There's lots of different ways to look at these particular parabolas, and the numbers involved in the equations are going to dictate what the parabola ends up looking like. It could open up, it could open down, it could open from the origin, or it could open off of the origin, above the axis or below. It could be anywhere in the four quadrants. Okay? Of course, there's more to it. But for right now, all I want you to do is practice the graphing of basic parabolas. So here's the goal for today. And I'll put it on the board. It's an IXL task, which some of you are doing great with, and others have yet to open. So please understand, again, these are homework assignments that count. Your IXL task for today is under the Algebra 1 menu. It is BB.3. BB3. And the goal, as usual, is to get to at least 85% with extra credit for those who get above 85%. That is all. So please go on to IXL. Please take BB3 and finish it quickly if you can, but no later than Thursday. Not that much time on this task. It's one task and it's not a hard one. Basically just graphing from a table of values. Good luck, and let me know if you have any questions. Have a great day.